Today I'm going to check what changes when I connect the subwoofer coils into series or into parallel. I have a sneaky suspicion that when the coils are in series, the coil itself won't get too hot as it would be when it's connected in parallel. To check this, I'm going to use a infrared thermometer, and I'm going to adjust the gain in both connections so that the power that the subwoofer coil sees stays the same in both experiments. First, I will be checking the connection in a parallel. I will be applying a 50 Hz sine wave for a minute and measure the temperature difference after the run. I will be using a single ground zero 15-inch driver with dual voice coils, each 2 ohms, and I can connect them into a 1 ohm connection in parallel or 4 ohm connection in series. Driver will be driven with a Taram Smart 3, and I will be adjusting the gain according to the needs for each run. Coil terminals are routed out to the box front, where I can connect the coils both in series or in parallel using these jumper cables. At a 1 ohm connection, when the coils are in parallel, I will be applying 17 volts to the coil. I'm targeting around 300 watts, but I will later check the actual wattage that I was applying. So let's go. So the coil now is 27 degrees. Let's start the cycle. And time, so let's quickly measure. Okay, now I'm seeing 43 degrees. And time. Okay, so now the coils are in series, and I will be aiming still at 300 watts, but now I have to adjust the voltage to be 34 volts. Okay, let's do it. So let's check the coil temperature. Turn to 27 degrees Celsius, and yeah, let's do it. So 3, 2, 1. And time. So the temperature quickly. Haha. Yeah, I was right. The temperature now is 32 degrees Celsius. So the increase was only about 5 degrees. Looks promising, but I still have to check actual wattage for each run. Let's clamp the series connection. Okay, so no need to measure any temperature at the moment. Let's see. .35 amps. Yeah, I guess I had to measure the actual wattage before I switched the connections, but I guess it's no problem if I adjust the voltage as it was. So let's do that. Now I have connected the subwoofer back into parallel, and I have adjusted the gain to be 17 volts again. Let's clamp the parallel connection. So you can see it's now 10.8 amps. Okay, let's crunch some numbers and I will get back to you. Okay, so let's talk about the results. The numbers are here and you can see them here. So let's start with the coils in parallel. I was measuring 1 ohm at the terminals and I was aiming at 300 watts of power. So with this simple equation I can calculate that I will need to apply 17 volts to the speaker to see theoretically this power. Before the test I was measuring the coil temperature to be 27.3 degrees, and after the 60 seconds I was measuring 43 degrees, which comes out to be 16 degrees Celsius temperature difference. So yeah, and just to check what was the actual wattage, I was clamping the terminals to see what's the amperage that's given to the coil, and I was measuring 10.8 amps and it gave me 183.6 watts of power. Talk about box rise. Okay, so and the next test was when the voice coils are connected in series, which gave me the reading of 3.8 ohms to the terminals. Again, I was aiming for 300 watts, and with this equation it came out that I should apply 34 volts to the speaker. Again, I was waiting for the coils to cool down to 27 degrees approximately, and after the minute of testing I was measuring 32 degrees, which is substantially lower than before, and it produced only 4.7 degrees Celsius temperature difference. It's it's 4 times less temperature climb, so it's quite substantial. And again, just to check that I was actually pulling similar amount of power, I did clamp the terminals and saw 5.4 amps of current, which came out to be exactly the same 183.6 watts of power. So yeah, this is quite interesting. The implications of this test are quite substantial. Let's start with that. If you have a single sub and you are planning to run it from a single amp, it's actually much more worse to run the subwoofer with the coils connected in parallel, because you are risking to burn up the coils. I can understand that this is quite tempting, because any other car amplifier boasts about that it can go with low ohms, and the obvious solution is to connect your single subwoofer to as low ohms as possible. But there's a twist. To produce the same power with the lower ohms, essentially when you're connecting the coils in parallel, you're losing half of your motor force, or the BL sum, which means you have to push the remaining length of coil twice as hard and apply twice as much current to get the same output essentially as it would be in a series connection. Or to put in other words, essentially what you're doing when you're connecting your single subwoofer in parallel is you're cutting the voice coil wire length in half, which means there is only 1/2 of the wire left to interact with the magnet you have, which means you have to push more power through the wire to achieve the same result. So in summary, if you have one subwoofer and it has 2 voice coils, it's recommended that you connect the coils in series to protect the voice coil from burning up. And if you have multiple subs, be sure to connect each driver in series, and after that you can just connect these multiple drivers in parallel to match your amplifier's ohm load. I hope I'm making sense here. You can correct me if I'm wrong, but that's the thinking I have. As far as I know, I haven't seen any discussion anywhere in the whole wide internet that goes in more depth how you should wire your subwoofers in series or in parallel, and what are the benefits and losses. So yeah, especially in YouTube, there are almost or literally no videos on this topic. So I hope to spark some discussion, at least maybe, with this. So yeah, if you have any questions or you would like to add something, or you spotted something that I did wrong, be sure to comment down in the comment section. And yeah, thanks.